Hello students, welcome to Vista's Learning. This is Shruti D. Nadiga, your chemistry tutor. We are in 11th standard. Yes, this Vista's Learning will work for the right to quality education for all, and we are here you to provide all the quality educations, and we have many videos which you can browse in the online platform. If you are not getting any of the videos, you can also subscribe to our web application www.v-learning.in. Students, we were doing the structure of atom and we have already finished 8 lecturing hours and this is the 9th one. Before going into today's session, I like to tell you something. I have been prepared for the exam. I will be daily studying. And what happened is that before going for the exams, I didn't study anything. And directly I was thinking, I know everything. I have studied daily and I just entered to the examination hall and then I was so nervous. I couldn't attend the exam. You know why? Because I didn't revise it. Daily we are studying different chapters. Each day we are studying it. But revision is very much important such that we can recollect the thing and make it like revision makes us very much perfect when we enter into the examination hall, or if anyone asks us the questions, we are very perfect to answer them. Getting this? That's why we are getting into the exercise and revision part today. We are having a couple of questions which will be answering this session. The first session is like this, first question is like this. Calculate the number of electrons which will get together in 1 gram. Like it is in 1 gram, how many electrons will be present? Can you guess it? Yes, students, we know the mass of an electron. So what is the mass of an electron? 9.1 into 10 raised to minus 28 grams. If it is present in the kg, then it will be minus 34 as we know. Right? So the mass of an electron in grams is minus 28 and in kgs it will be minus 31. So you need to remember that. Why we are taking in grams? We are not taking in kg. Why? So I can take this in kgs, isn't it? Why I'm not taking in kgs? Because here the question is asking for 1 gram, how many electrons are there? So we need to know that if I take in kgs, again I have to convert it. So what we need to do, mass of an electron in grams itself, we can directly take it. Then we know that 9.1 into 10 raised to 20 minus 28 grams contains 1 electron. That means for 1 electron, how many, for 1 gram, how many electrons, we can easily find it out. So 1 gram is equals to 1 divided by 9.1 into 10 raised to minus 28 grams. Right? So here you can get 1 gram consists of 1.098 into 10 raised to 27 electrons. Can you imagine? 1 into 10 raised to 27 electrons are present in 1 single gram. Understood? Fine. Next question is, calculate the mass and charge of 1 mole of electrons. As we know, what is this 1 mole? 1 mole is equals to Avogadro number of electrons or any of the particles. So regarding that, we can find out the number of electrons present in 1 mole. So 1 mole of electrons is equals to 6.022 into 10 raised to 23 electrons. So 1 mass of electron is how much? 9.1 into 10 raised to minus 31 kg. Listen, here we are taking in kilograms. There we took in grams. What is the difference? Here we require in kg because mass we know will be taking in kg generally. There, why we took grams? Because 1 gram, how much the electrons are present. So according to the question, we need to check the units. Here again, the mass of 1 mole of electrons. 1 mole of electron is equals to these many electrons. So we can say mass of these many electrons is equals to how much? that will be mass of the one electron into the number of electrons. For example, if I say mass of one apple is equals to 10 grams, then if I have 5 apples, what do you do? 5 into 10, right? So I'll get 50 grams. Taking that all the apples will be having same mass, okay? So likewise, here also the mass of one electron is equal to this much. Mass of 6.022 into 10 raised to minus 23 electrons will be equal to the mass of one electron into the number of electrons what they have taken. Understood? So that 1.602 into 10 raised to minus 19 coulomb. Hope you know this, students. One electron will always have 1.602 into 10 raised to minus 19 coulomb. That is the charge in coulomb. Fahrenheit, Faraday, it will be different. One charge of 1 mole of electrons is equals to how much? We found out the mass of 1 mole of electrons. So now we need to find out the charge of 1 mole of electrons. That is the same thing. 1 mole, we know that the Avogadro number of electrons will be present. So that into the charge for 1 electron, if you multiply, you will get the answer as 9.65 into 10 raised to 4 coulombs. Got this? Good. The next question. Calculate the total number of electrons present in 1 mole of methane. So here they are not just asking 1 mole of some substance or 1 mole of electrons. Now they are giving you methane. Here you need to know what is methane. Methane is nothing but the first member of hydrocarbon, that is CH4 is the formula of methane. Now we'll check how many electrons are there in 1 molecule of methane. Then we'll be getting to know how many electrons totally are present in 1 mole of methane. So 1 mole of methane, if you take, it will be again having how many molecules of methane? Avogadro number molecules of methane. So number of electrons present in 1 molecule of methane is how much? We know carbon will have 6 as a atomic number and hydrogen will have 1 as a atomic number. So that means 1 carbon has 6 electrons, 1 hydrogen has 1 electron. How many hydrogen we are taking? 4 hydrogen. So that means 4 into 1. So 6 plus 4 into 1, you'll get 4. So 6 plus 4 is 10. Totally, how many electrons are present in 1 molecule of methane? 10 electrons. That means for 10 electrons are present for 1 molecule, then how many electrons are present for 1 mole of molecule? We need to check. So for that, the number of electrons present in this Avogadro number, that means 1 mole of methane is equals to that Avogadro number into 10, that gives you 6.022 into 10 raised to 24. Don't get confused, both are same. The into 10 is there, so that 10 if you add 23 plus 1, so you'll get 24. Because in mathematics you have studied, if you have 10 raised to 1 into 10 raised to 2, then what happens? The exponents gets adds up. So we'll get, when it is being added up, 1 plus 2, so we get 10 raised to 3. Likewise, 110 is multiplied with this, then it will become 10 raised to 24. Got it, students? Fine. The next question is that, what is the question? Yellow light is being emitted from the sodium lamp as a wavelength where you have of 280 nanometer. Okay, calculate the frequency and wave number of the yellow light. Is this correct? The 2 it is being given, that should be lambda. Okay, fine. Lambda is the representation of wavelength, mu is the representation of frequency, and mu bar is the frequency, like wave number. Okay, fine. What is the question they are asking? The yellow light is being emitted from the sodium lamp. And what you need to calculate? You need to calculate the frequency and wave number. They have given the wavelength. Wavelength means lambda they have given. So calculation of frequency of yellow light. What we know here? Mu is equals to C by lambda. We have this formula, right? So by using this formula, we can find out mu and C. What is the C here? C is the speed of light. Lambda is the wavelength of given light or radiation. What they have given? 580 nanometer. So as you see here, C, you have C is equals to 3 into 10 raised to 8 meter per second. That is constant. Okay. And lambda, what they have given? 580 nanometer. And you can take nanometer as 10 raised to minus 9 because we know that we need to take it in meters. The wavelength, if they have given in nanometers, 10 raised to nanometer means 10 raised to minus 9 meters. So you can just convert this and it will be easier for you to simplify the question. So mu is equals to, on substitution of C and lambda, we get 3 into 10 raised to 8 meter per second divided by 580 into 10 raised to minus 9 meter. That gives you the answer as 5.17 into 10 raised to 14 per second. That is the frequency of given yellow light with wavelength 580 nanometer. Now we'll calculate the wave number. What is the wave number? What is the formula for wave number? We know that mu bar is equals to 1 by lambda. That is, wave number will be reciprocal of wavelength. So you can get 1 by 580 or 580 nanometer, that is 10 raised to minus 9 meter. What is the reciprocal of that? You'll get the answer as 1.724 into 10 raised to 6 per meter. This is the wave number. So what the question was asked, they have given the wavelength. We need to find out the wave number and frequency. Hence it is done. Isn't it easy, students? Good. Next, what is the fourth question? It's a fifth question. What is the number of photons? Photons, you know, it is the exact quantized pack of energy which is coming, right? That photons of light with wavelength 4000 picometer. PM means picometer, which provides 1 joule of energy. So here we need to find out, for getting 1 joule of energy with wavelength 4000 picometer, what the photon should have. What is like how many photons the light should have. That is what we need to find it out. So how to find this out? Energy of photon is having E is equals to h mu, right? E is equals to, it will be E is equals to h mu. And mu, we know that. What is mu? Mu is equals to C by lambda. So you can use that here, h C by lambda. Then what is the value of this? Should be h C by lambda. Okay, fine. So here what is the value of h? As I said in the previous sessions, h is the Planck's constant and it is the constant. We need to remember that. So it will be 6.626 into 10 raised to minus 34 joules second. And we have C. As I said, the C is the speed of light. It will be always 3 into 10 raised to 8 meter per second. And what is this lambda? Lambda is the wavelength what they have given. 4000 picometer. As I said, picometer, you remember the first chapter we studied, the notations, scientific notations, how it will be. So there you have learnt what is picometer, what is micrometers and all, right? If you are not, please go back to the web application and get the videos, see through it, study, and you'll understand it better. So we have picometer, which is equal to 10 raised to minus 12. So 4000 into 10 raised to minus 12 meter will be called as lambda is equal to 4000 picometer, and you can convert that into nanometer. So as we know the 3 zeros are there, if you shift the decimal point 3 decimal point towards 4, then you'll get 4 into 10 raised to minus 9 meter. So it will be giving you 4 nanometer. For simplification, you can just apply or substitute the values of h, c and lambda such that you will get the answer of energy of photon. So that will be equal to the h. What is the h? 6.6 into 10, like 6.626 into 10 raised to minus 34 into 3 into 10 raised to 8 divided by 4 into 10 raised to minus 9. You need to remember we have taken the nanometer here. And that gives you the answer as 4.969 into 10 raised to minus 17 joules. So this is like 1 joule of energy of photon is equals to 1 by this. That means you know that energy of photon, what we got is this much. For 1 joule, how much? Like this is 4.969 joules we have the energy. For 1 joule, how much photons we have to find it out. So for 1 joule, it will be 1 divided by 4.969 into 10 raised to minus 17, where we get 2.012 into 10 raised to 16 photons. So these many photons are present in 1 joules of energy, where the light is having 4000 picometer as wavelength. Next question. A photon of wavelength, they have around 4 into 10 raised to minus 7 meter, strikes some metallic surface, and the work function of the metal being around 2.13 EV. What is this EV? Electron volts. And calculate the energy of photon, the kinetic energy of the emission, and also the velocity of the photoelectron. So this is what 3 sub questions we have to find out. Kinetic energy we need to find out. We need to find out the energy of the photon and also the velocity of the photoelectrons. Photoelectrons means how fast the ejected electrons are moving. The speed of the electrons we need to find it out. So how to do this? What and all they have given? You can see the wavelength they have given. Wavelength of the like light which is striking is been given, and the work function is given here. So by using work function and the wavelength, we can have E is equals to hc by lambda, because we know lambda here. So you can substitute lambda. E, h you know, h is the constant, c is the constant. So you can substitute and get the photons here. Like you will get the energy of 1 photon, like energy of the photons which is being used, you can find it out. So you will get around 3.1 EV, electron volts. So what is this EV? How to convert this EV? We already have joules, right? We need to convert joules to EV. So here 1 electron volt divided by the 1.602 into 10 raised to minus 19 joules. That gives you the value of 1 EV. So that into 4.97 into 10 raised to minus 19 joules if you do, you will get the electron volt of the photons which is being used here. Then the kinetic energy of the emission we need to find it out. So energy of the photon, did you understand? You can give the energy of the photon in joules, or else you can take it in EV. Why we are taking it in EV? Because here the work function is mentioned in EV. So we need to convert that joules into EV. Got it? Good. So kinetic energy of emission. What is this kinetic energy? Obviously we know it will be half mv square. So here, but we are not using that kinetic energy formula here. Why? Because the work function is given. When we know the work function, we also know the energy of the photon, and it will be easier for us to find out the kinetic energy. Why? Because the energy what the photon is having, and while it is striking, and we know the work function of it, like at what it is been coming out, what is the minimum energy it requires, we know. And by that, if you just find out the difference between the energy what photon is having, which is striking on the metal, and the work function, we can directly find out the kinetic energy of that electrons which are emitted. So the kinetic energy of emission, or electrons which is been emitted, will be equal to E minus work function. Why you took the EV, did you understand now? If it is in different units, it will be very difficult for you to get the exact answer. Whenever you are subtracting or adding or dividing, you should know about the values. I mean units. So these units are very much important. When you are subtracting and when you are addition or subtracting, you have to remember that they should be in same units. So if I take it in joules and if I take the work function in EV, then it will not give you an accurate answer. That's why we converted 1 joule into the EV. So here, energy minus work function. Energy is 3.1 EV minus the work function 2.13 what they have given. That gives you 0.97 EV. The next question, the velocity of the photoelectrons. We need to find out the velocity. Now we are taking half mv square. Why? Because we know the kinetic energy of the emitted electrons and we know the mass of the electron. We just have to find out the velocity. So v square, if you take, you'll get the answer here. By substituting this electron emission, we have 0.97 EV, that is kinetic energy, that into 1.602 into 10 raised to minus 19 joules into, you will get the answer as this much, kg mass square by per second square, you will get this, and from there you can find out this v square. That is, v is the velocity of the energy, electrons which is emitted. V is equals to 2 because this 2 goes into the numerator, from denominator to the numerator, that into electron, kinetic energy of the electron. They have taken from EV to joules, that you have to remember. So either you are converting from joules to EV to joules. This number is very much important. 1.602 into 10 raised to minus 19 joules. If you are converting joules to EV, you need to take reciprocal of this. If you are converting joules to EV, then the value you have to you are converting joules to EV, then the value into 1 divided by 1.602 into 10 raised to minus 19 if you do, then this will convert into joules to EV. If you want to convert EV to joules, then the value, whatever the value you have, that into 1.602 into 10 raised to minus 90 if you do, then that will be converted from EV to joules. Okay, so here we have the conversion of EV to joules. So we are taking this as a kinetic energy into that divided by the mass. Then because mass is an numerator, when it be transferred, it will come to the numerator. So this will give you in mass, that will be equal to, mass of electron is 9.1 into 10 raised to minus 31 kg. They have to take in kg here, not in grams, remember that, into 0.34 into 10 raised to 12 meter square per second square. So this is the value what you get here. Or else you can also take this like this, when you have v square is equals to this. We don't want v square, we want just v, velocity, right? So for that you have to transfer the square to the other side. When you have v square is equals to x, we have learnt in maths that V is equal to square root of X. Isn't it, students? So that is what we are taking here. We can write the square root here for all, or we can also take this as 1 by 2. If you take 1 by 2, that means square root of the given value. So square root of 0.34 into 10 raised to 12 meter square per second square will be equal to 0.583 into 10 raised to 6 meter per second. And that you can just slide it on the one hand side, like one left hand side towards the 5, then the decimal point if you shift, you'll get 5.83 into 10 raised to 5 meter per second. This is how you can find out the velocity of photoelectron and kinetic energy of emission of electron and also the energy of the photon. The next question. Hope you are understanding, students. If you have any doubts, you can get back to us. Yeah, the photon of wavelength with 4 into 10 raised to minus 7 strikes the metallic surface. This we just did. Yes, we just did this. Yeah, we'll just go with the next question. How much energy is required to ionize hydrogen atom if the electron occupies n is equals to 5 orbit? Are you understanding the, students? When you have a hydrogen and that electron should be removed from that orbit. As we know, hydrogen is having one electron, one proton in the nucleus and one electron which is revolving. And what they are saying, you need to ionize the hydrogen atom such that the electron occupies the 5th orbit. That means it will be having 5th orbit. This electron should jump to the 5th orbit and then we can say the hydrogen has occupied almost the positive 1 charge. So that is what they are saying, like if you have to ionize the hydrogen atom by shifting one electron to the 5th orbit. And compare your answer with the ionization enthalpy of hydrogen atom, what it is being given. We'll just check with us. So here we have the ionized energy which is been required for nth orbit, right? We have studied En is equals to minus 2.18 into 10 raised to minus 19 into z square divided by n square. Z square gives you the atomic number of the atom what we are taking and n gives you the number of orbits. So here the atomic number of an atom, principal quantum number as the orbit, number of orbit, and also the ionization energy from like 1 to 2. Like it is going from 5th orbit to the infinity. It has been jumping out. Getting that? Yes. So here delta E, the change in energy will be equal to E infinity minus E5. That means infinity it is completely removed away from the electron. Where is the electron in the hydrogen? It is in the 5th orbit. Got it? It is in the excited state. From there you are just removing out from the atom and you are giving the positive charge to the atom. So what will be the answer? We know that En will be equal to, you just saw here, En is equal to this formula, right? So here we have 2E, E infinity and En, or it will be E5. So by just substituting here 1 square, why we are taking 1 square? Because hydrogen has atomic number 1. So we get 1 square divided by infinity square. Why infinity square? Because here E infinite, electron has been jumped to the infinite orbit. And here like similarly for hydrogen we have taken, so Z is equals to 1 and N will be equals to 5. So 5 square we are taking. And here we know that 1 divided by infinity will be equal to 0. So since it is 0, this value will have no value or it will be 0. And so we can take this as 0, and we know this minus into minus plus, so you don't have any charge here. 2.18 into 10 raised to minus 19, 2.18 into 10 raised to minus 19 into 1 by 5 square you have. We know that 1 by 5 square means 1 by 25, because 5 square is 25. So by substituting that value, we get the value as 0.0872 into 10 raised to minus 19 joules. So here again, just if you shift the decimal point, 8.72 into 10 raised to minus 28. You should remember it is minus 18. When you shift towards the right side, then it will become addition of negative sign. So it increases. So if you are shifting on the other side, it will become positive. Please do remember this, don't get confused. So here the value of the difference of energy will be equal to 8.72 into 10 raised to minus 20 joules. Next, since the energy required for ionization from n is equals to 5 to the n is equals to infinity is 8.72 into 10 raised to minus 20 joules, the energy required for n1 is equals to 1, like from 1 to infinity, will be equal to this. So again the same thing, delta E is equals to E1 minus, it's E infinity minus E1. So here what happens? The E infinity, as I said, 1 by infinity is equals to 0. So this will leads to 0, and this value will be remaining minus into minus plus 2.18 into 10 raised to minus 18. Here also 1 square, here also 1 square. 1 square into 1 square will be equal to 1. So that is what we are getting for first energy to the infinity. So 2.18 into 10 raised to minus 918 joules. So hence the less is the energy required to ionize an electron in the fifth orbital of hydrogen atom as compared to that of the ground state. From this what you can understand, if the electron is in the outermost shell, you can easily remove it. If it is in the inner core shell, then it will be very difficult for us to remove because more energy is being spent. Yes, students, by this, Vista's learning will provide you a quality education for all. This is the chemistry class 11th standard structure of atom as we have been revised today. I hope if you have any doubts, you can just get back to us and we'll be always here provided for all the doubts whatever you are having. Thank you for watching.